Hello there everyone, nice to see you once again. We've been doing Introduction to Three-Dimensional Geometry, the chapter of 11th class, and today we are going to discuss the last topic of this chapter, that is section formula. You must have studied section formula in 2 dimensions only in your 10th class, and you can have a look at the videos of coordinate geometry as well. They are already made by me, so you can watch them through the playlists. So the section formula in 2 dimensions is already explained in 10th class, but we are now talking about 3 dimensions. So for example, consider 2 points. The coordinates are x1, y1, z1 and x2, y2, z2. Consider a point P. The coordinates of P are x, y, z, and P is dividing the line AB into 2 sections of ratios m and n. So you have to find basically the coordinates of the point which is dividing the line into 2 parts, or the parts, how many parts are given. Now x will be equal to mx2 plus nx1 upon m plus n. Y will be equal to my2 plus ny1 upon m plus n. Now we have done these two formula, the formulas of these two coordinates, but now of course the third dimension is involved, so z will be equal to mz2 plus nz1 upon m plus n. So you will simply fill in the values of each and every variable which is being used, and then you can find the coordinates of the required point. Here is one more thing. There are two things, internally and externally. If a point is internally intersecting or dividing the line, then the formula of the coordinates of that point is these three. But if the point is dividing the line externally, then n will be changed to minus n. Only this will be the difference, and your formulas will automatically become mx2 minus nx1 upon m minus n, my2 minus ny1 upon m minus n, mz2 minus nz1 upon m minus n. So just keep this thing in mind, that if they are saying the point is dividing the line in ratio internally, then there will be positive n, otherwise n will be taken as negative if it is given that the point is dividing the line segment externally, right? So there's one more thing, one extra tip is that if the ratio is not given in any sum, we consider ratio to be k/1, and in this way we can find the value of k, and the desired ratio will be found out at the end. So this was an extra tip, that if the ratio is not given, just consider the ratio to be k/1. So we will be implementing this formula on the examples only. So let's commence with the examples. This is our very first example. In this we have to find the coordinates of the point which is dividing the line segment joining these 2 points. The ratio is given, it means x1, y1, z1, x2, y2, z2, as well as m and n is given, and we have to find the coordinates of the point which is dividing this line internally as well as externally in the given ratio. So firstly we'll simply find for the internally. So what's the formula? X is equals to mx2 plus nx1 upon m plus n, right? So what is m? That is 2. What is x1? That is 1. Then plus what is n? That is 3. And what is x1? Here it was x2, it means it was 3 here, and here it is x1, it means 1 would be here. M plus n, it means 2 plus 3. So simply after solving 2 3s are 6 plus 3 9 upon 5. So similarly we can do for the y, my2 plus ny1 upon m plus n, right? So what's m again? 2. What is y2? That is 4. Then plus what is n? 3. Then what is y1? Minus 2 upon 2 plus 3. So 2 4s are 8 minus 6, that is 2 upon 5. We can do for z, mz2 plus nz1 divided by m plus n. So what we can do, what is m? That is 2. What is z2? That is minus 5. Then plus what is n? 3. What is z1? That is 3 upon 2 plus 3. it will be minus 10 plus 9 minus 10, that is minus 1 upon 5. So the coordinates of the point internally are 9 upon 5, 2 upon 5 and minus 1 upon 5. These are for internally. We are going to talk about externally as well. So x will be equal to mx2 minus nx1 upon m minus n. As I have told you earlier that n will be changed to minus n, that's it. Mx2, it means 2 and 3 minus 3 and 1 upon 2 minus 3. Of course minus 1 will be in the denominator, so 6 minus 3, that is 3 upon minus 1, that is minus 3. Or simply you can say the sign will be changed to minus only. So my2 minus ny1 upon m minus n. So what is m? That is 2 and y2 4 minus n y1 is minus 2 divided by 2 minus 3, this is 8 plus 6, that is 14, and minus 1 in the denominator, so minus 14 will be the coordinate, the y coordinate, and z will be mz2 minus nz1 upon m minus n. So mz2, it means 2 then minus 5 then minus 3 of 3 divided by 2 minus 3, so minus 10 minus 9, that is minus 19 upon minus 1, that will be 19. So the desired coordinates are minus 3 minus 14 only 19. Now these are the coordinates when the point is dividing the line segment internally, and these are the coordinates of the point which is dividing the line segment externally. So simply you can we have just implemented the formula and we have just filled in the values which are given, and in this way we have found the desired coordinates of the points which are dividing the line segment joining these 2 points internally as well as externally. So this is how to do this. Let's move to the next example where we have to make some of the assumptions as well. This is next given example. In this we have to prove that these 3 points are collinear. It means these 3 points are lying on a single line. So what's the method, what's the working method? Just let these points be A, B and C, and firstly apply the section formula on the line AB only. For example, it's a line minus 4, 6, 10 and 2, 4 and 6. So AB. Now the ratio is not given, so as I have told you earlier that we'll consider the ratio as K ratio 1. We are not considering the point C. Why? I will be telling you shortly. So the ratio is K ratio 1. You have the coordinates as well, so let this point be P. So the x coordinate of P will be, of course, that is mx2 plus nx1, right? So mx2, what's n? That is K, and 2 is our x2, so mx2, that is 2k plus nx1, 1 minus 4, that is minus 4 upon m plus n, that is k plus 1. What will be the y coordinate? my2, it means k multiply 4 plus ny1, that is 1 multiply 6 divided by k plus 1. And what will be the z coordinate? That is mz2, like k 6k plus nz1, that is 1 multiplied 10, so 6k plus 10 upon k plus 1. So these are the coordinates of point P, right? Now we have to prove that ABC are collinear. Let's suppose that for any value of k, the point C is coinciding with P. It means if P is here, then C is also here. Let's suppose this. So now we have supposed that P and C are coinciding. So of course the coordinates of P and C will be equal to each other. So we can equate X, Y or Z, any one of these 3 coordinates. So let's equate Y. So 2k minus 4 upon k plus 1 will be equal to 14, and from this just find the value of k. What will you do? 2k minus 4 will be equal to 14k plus 14, 2k minus 14k minus 12k, 14 plus 4, that is 18. So k will be equal to 18 upon minus 12. It means 2 9s are 18, then 6, then 3 3s are 9, 3 2s are 6. It's minus 3 upon 2. So the value of k is minus 3 upon 2. Now what we are going to do, we have equated the x coordinate of point P and C. Now we have to prove that the coordinates of P are equal to C, the remaining coordinates. It means 0 and -2. So we have also found the value of K. We will just simply substitute the value of K in Y and Z coordinate, and we will see if these coordinates are becoming equal to the Y and Z coordinates of point C. Only then A, B and C will be called as collinear because they will be lying on the same line. So what's the value of K? It's -3/2. Find the coordinate Y coordinate. Y is equals to 4. What is K? -3/2. Then plus 6 upon K plus 1, that is -3/2 plus 1. So we have to get 0, right? So 2 2s are 4. -6 plus 6, yeah. So Y coordinate is 0. Let's move to the Z coordinate. So Z will be equal to 6 multiply -3/2 plus 10 upon -3/2 plus 1. We have to get -2 from here. So 2 3s are 6. It's 10 minus 9. That is 1. 6 multiply K. That is -3/2. So 2 3s are 6 minus 9 plus 10. That is 1. And this is 2 minus 3 plus 2 upon 2, so that 2 will be here only, and 2 minus 3 minus 1, so minus will be in the numerator. So -2 is your Z coordinate, which is the Z coordinate of point C. It means C and P are coinciding, which means A, B and C are collinear, and P is none other than C. P and C are equal to each other, they are coinciding. That's why the position of C will be here only. So in this way we have proven that A, B, C are collinear points because they are lying on the same line. So just you have to equate one coordinate of P and C, find the value of K, and then substitute that value of K into the other two coordinates of point P, and just see if the values are coming out to be the rest of the coordinates of C point. If yes, then yes, these points are collinear. If no, then no, these points are not collinear. Let's move to the next example. This is our example 9th, and in this we have to find the coordinates of the centroid of the triangle. I have already drawn the diagram for you. So the vertices of triangle are ABC, x1 y1 z1, x2 y2 z2 and x3 y3 z3. We have to find the coordinates of the centroid, that is G. So it's already proven, it's already known that the centroid is like dividing the median AD in the ratio 2:1. So this side is 2 and this is 1, right? So it means if there is a median AD, and of course centroid G is lying on that median, so G is dividing AD in 2:1. So we will be simply applying the section formula on the G, because we have to find the coordinates of G, right? So but for that we must be knowing the coordinates of D as well. So of course, as I have told you that AD is the median, it means D is the midpoint of BC. So we can apply the midpoint formula on D. So the x coordinate of D will be x2 plus x3 upon 2. Y coordinate will be y2 plus y3 upon 2, and Z coordinate will be z2 plus z3 upon 2, because you know what is midpoint formula, the sum of x coordinate plus y coordinate divided by 2, the mean of x and y coordinate. So we have got the coordinates of D as well, that is x2 plus x3 by 2, y2 plus y3 by 2, z2 plus z3 by 2. So you have ratio, you have the end coordinates as well, you can simply apply the section formula. So what will be the x coordinate of G? Now for point G we are solving. What will be the x coordinate? That is mx2 plus nx1. So you can see that what is our m, that is 2, x2 is our this, x2 plus x3 upon 2 plus nx1. What is our n? That is 1. What is our x1? That is x1 itself. So this is the thing, divided by m plus n, it means 2 plus 1. Similarly, we will be applying the section formula for the y coordinate, that is 2 y2 plus y3 divided by 2 plus y1, of course 1 multiply y1 and again 2 plus 1. Similarly for the z coordinate, which will be mz2, that is 2. What is z2? Z2 plus z3 upon 2 plus nz1, it means plus 1. What is z1? That is z1 itself, divided by 2 plus 1. So just solve it a bit. 2 and 2 will be cancelled in every equation. So what you will get, the coordinates are x1 plus x2 plus x3, x1 plus x2 plus x3 upon 3, then y1 plus y2 plus y3 upon 3, then z1 plus z2 plus z3 upon 3. So these are the required coordinates of the centroid of the triangle whose vertices are given, right? So this is x coordinate, this is y coordinate, and this is z coordinate. So the vertices of the centroid of the triangle can also be remembered as a general formula of the centroid of the triangle. So just keep this formula in your mind because you will be using it at certain places. Let's move to the next example. This is the last example of this chapter. It's to be find, the thing which is to be found is the ratio. So find the ratio in which line segment joining this and this is divided by YZ plane. So we have to find the ratio in which these 2 points are forming a line and that line is being divided by YZ plane. So we will be firstly finding the coordinates of P. For example, this is a line AB, right? And it is being divided by YZ plane. So it means the point P which is dividing the line AB is lying on YZ plane, right? YZ plane means the X coordinate will be 0. So the X coordinate will be 0 and rest 2 we can find by just applying the formula, section formula. And firstly we'll consider that the ratio is k ratio 1 as I have told you. So the ratio is k ratio 1 and firstly find the coordinates of point P. Then we will equate the x coordinate of P to 0 because it is being divided by YZ plane. So firstly what will be the x coordinate? That is mx2. It means k and 6. So mx2 that is 6k plus nx1 that is 1 and 4. So 6k plus 4 upon m plus n that is k plus 1. Similarly find the y coordinate. What is it? Y coordinate is my2 k multiply y2, it means 10k plus 1 multiply 8 that is 8 divided by k plus 1, and z will be equal to mz2 k multiply minus 8, so minus 8k plus 1 multiply 10, so it means 10, so upon k plus 1. So these are the 3 coordinates of point P. Now it is being divided by YZ plane, so x coordinate will be equal to 0. 6k plus 4 upon k plus 1 will be equal to 0 simply. So 6k plus 4 will simply be equal to 0. From this 6k will be equal to minus 4 and k will be equal to minus 4 upon 6. 2 2s are 4, 2 3s are 6. The value of k is minus 2 upon 3, or what was the ratio? So the ratio was k ratio 1. So our ratio will be minus 2 upon 3 ratio 1, or in the simplest form it will be minus 2 ratio 3, right? So there they have found the answer in the form of external ratio. So of course the external ratio, the one ratio will be negative. So simply 2 ratio 3 will be our answer if we are talking about the case in the external case. But if you are talking about the internal case, then this is your final answer. So in this way, by considering ratio to k ratio 1, you can find the ratio, and you can prove the collinearity of the points. You can apply the section formula very simply. So this was all about section formula, and with this the introduction to three-dimensional geometry is finished. You can start your exercise and you can do the sums. If you have any problem, any doubt, any query, suggestion, you can use the comment section, or you can DM me on my Instagram handle. It's given in the description. So keep practicing. All the very best. Don't forget to subscribe my channel before leaving it, and also share it with your classmates, your friend, and your known ones. So thanks a lot for watching my video, and I'll see you in the next video. All the very best.